if I speak loudly that way, I'll just, how do you do, Bob? Looking good. So this project is across Ontario and Quebec, and so we've got the Saint people involved on the Quebec side and a couple of researchers at universities over there as well. And they've got as you know, a really well-developed research program for looking at biomass crops. And so I want to start off with the acknowledgement slides and who's all involved. Of course, we are. It's a couple of universities. There's you guys. There's the Ontario Agri-Food Innovation, who's paying for this, and then the Quebec, the RPBQ, that group. And it's, I don't know if any of you guys know Snejana Olskaya, who's running that program out of a town called Belleuil. And actually, she said they have an acknowledgement message. And the message is that the sampling was done on plots of various cultivars of switchgrass in Kansas established in 2010, which isn't quite true. They're all over the place, as part of the Quebec Bio-Industrial Plants Network funded by the Quebec Ministry of Agriculture, Fisheries and Food. And I would say it again in French, but it'll take too much time. And how I speak French, so this made a huge difference in actually getting the field work done, because some of the places were quite remote last year. So we have heard a lot about what carbon can do in soils under biomass crops. And the next step that we're taking with this project is looking at depth. There's a few things we're looking at, but one of the important things is actually that biomass crops root deeply. And I got a couple of examples there. You've got switchgrass and a couple of other things. Obviously, I've stolen this from a website somewhere. A lot of people want to see compared to your front lawn, and you can see that actually your front lawn does not root all that deeply. If we compare it to annual crops, well, annual crops don't really root as deeply. Part of it is that they're annual, they're not perennials. And so I sort of tried to line them up here. If these are all both in the depth and feet, you can even see that the corn only goes down to about 3 feet, but these guys suggest that switchgrass can go all the way down to 9 or 10 feet. And deep carbon is all the rage right now among the carbon sequestration people. They want to know more about what's going on in carbon at depth. And in fact, one of the interesting debates is when we report carbon stocks, we go down to 1 point, so 30 centimeters. And maybe that's not the right approach. Maybe we need to start thinking about carbon stocks that are deeper. So the other thing about root carbon versus residue carbon, I might use the laser pointer, but I don't know, just talk. Often what we do with soil carbon is we try to break it up into pools so that we can study them a bit easier. One of the easy ways to do it is to just separate it based on size. The smallest sieve you can buy is 53 microns. Just so happens that that's also the smallest size of sand that we categorize or that we characterize. Absolutely no coincidence there whatsoever. That's sarcasm, by the way. But anything bigger than 53 microns we call particulate, and we usually think of that as being from plants and easy to degrade because it hasn't bound with anything. And then anything smaller than that, we think of as being stuck to some kind of mineral. And that mineral tends to protect it. And why is that important? Well, it's important because a lot of the things that end up on a mineral originally come from dead microbes. The plant material that degrades is the bigger pieces. Microbes consume whatever it is that's there, and when they die, they actually die on surfaces. And I like this picture because they've got little glow-in-the-dark images of microbes that are living on surfaces. They're not floating around in the breeze, they're actually on surfaces. And so when they die, they stabilize, and they are really hard for that material to decompose. And you think of that pool as being the pool that lasts longer, sort of the pool that contributes to more long-term carbon sequestration. Now, if you add roots into this mix, roots release root exudates. And root exudates are really, really available to these microbes. And that's why around roots, you have a huge microbial population. They just grow and thrive on those exudates. But they also die. And so what happens is the roots feed the microbes die on surfaces. And so you end up with this interesting pump where the plant is putting carbon below ground, microbes grow and stabilize it just because that's where they die. Here's a nice picture of what a washed switchgrass root mass might look like. So I don't think I have to sell you on the idea that there's a lot of root mass associated with these plants. And if you put all these ideas together, there's a pathway here for biomass crops with your deep rooting and big root masses to sequester carbon deeply through the sort of microbial carbon pump. That's what they're calling it now, the microbial carbon pump. And so that was the idea. That's the whole idea behind the project. What we want to do is we actually want to go with deeper poles. We're going to go down to 1 meter. We're interested in looking at the total carbon throughout that soil profile. We're going to be doing the same thing that Naresh did with this carbon fractionation. And I'm so happy that you talked about it because I was racking my brains trying to figure out how to explain it. And I don't have to, it's beautiful. The other thing that we're interested in is this idea of carbon stability. That means, can it resist decomposition? And this, using a technique that's kind of become my thing, an analytical pyrolysis approach. And then the final thing we want to do is actually just look at the root architecture. And that's what one of the researchers out of Quebec is specializing in. And that's actually us collecting samples in Quebec. What are we trying to do? Well, we're trying to look at different geographical regions. So southern Ontario all the way up to quite far down the St. Lawrence. There's some commercial biomass producers as well as the research farms. And we're also really interested in comparing varieties. And so a lot of biomass differences, a lot of regional importance for these different varieties. So the ones we picked, at least in Quebec, are these Cave and Rock, Blue Jacket, Sundance, and Big Rock. And there's a few crosses in there as well. And I'll be honest, I'm still trying to learn what those crosses are and get that all figured out. For the Miscanthus, I missed one here. It's supposed to be Europa in there as well. So there's the two, Nagara and Europa are the ones that we're using. Those are my 2 summer students. Gosh, they're great. So here's a map. This is where we went last summer. So we prioritized the Quebec side because we were worried that actually they were going to lose their funding for their research plots. We went out there and we collected samples from 4 research farms and 2 commercial farms. You can see one of them, La Pocatière, like is way far down the river. Beautiful, by the way. But that's supposed to be our cold region that we're working with. And then some of the other ones there around managed by Miguel, by Sagon, and also by Laval. And then I'm putting this map on here. I stopped using some names that Naresh helped me with. And I know these are a lot of you guys. What we're hoping to do is prioritize the Ontario side this summer. And one of the reasons I'm here talking about this, but the same reason as Emma, we're interested in figure out what exactly it is that you guys have and go up and try and do some of the same sampling down here in Ontario. So there's just an aerial view of what they're doing in Quebec. You can see they've actually got replicated plots there with these different varieties. It's a wonderful site. So the way we do it, these are my 2 summer students. We got a modified post pounder, and post pounder has a hollow core on it that we run into the ground down to 1 meter. It's loud. The thing heats up like crazy, but it does a really nice job and it lets us go on foot into these different areas. So what you end up with is like a core about 1 meter long. You can see there's different. Well, try and imagine with me now that there's different horizons and that sort of you can see as you go down through it. And so what we're interested in, and obviously I've done this to highlight the point that there are different horizons. We're going to segment, so we're going to go at these different depths. These kind of line up with the international standards for soil sampling depths down to 1 meter. And then we're going to be tracking the carbon through the profile and with the focus on surface carbon, but also carbon at depth. So what are we going to research? Well, we're really interested in this idea of carbon additions and stability. And shall I mean, put in a slide, thank you, Naresh. The idea here is we know that the biomass crops have a different carbon signature compared to the annual crops. And so we're going to follow that as well. And we're really going to follow it all the way down through that profile. So surface soils, but also how much are these biomass crops contributing at depth? One of the Quebec people is kind of an expert on this. which is great. I know enough to get myself in trouble. That's why we have them around. The other one, this is where I come in, is this idea of carbon stability. So this is resistance to decomposition. And what I use is a technique called temperature controlled pyrolysis. I think a lot of you guys in biomass know about pyrolysis. So it's heating without air. And so instead of burning things, you're actually breaking things apart. You're breaking bonds and you're actually volatilizing the things that come off. What I do is I run it over a ramp of temperatures and I measure in real time how much carbon comes off. And what we're finding is carbon that comes off at a low temperature translates to more bioavailable carbon in the field. And this is proving to be a very useful technique. I mean, the gold standard is you go out and you let the microbes decompose your organic matter and you measure how much carbon dioxide comes off, and that's how bioavailable it is. But that takes 4 months. It's not very, you don't want to do that. So this lets us sort of give a good prediction quickly. The analysis takes like an hour or something like that. And it works. This is some results from a study that we did in New Zealand. On the x-axis, you have the amount of carbon inspired. So that's the bioavailability part. And on the y-axis, you have the temperature at which half of the carbon came off under pyrolysis. Lower temperature means easy. Higher temperature means stable. And there's a really good relationship between those two measures. And so that's something that I've been using in a whole bunch of different projects, of which this is one. So what's the expectation? Well, we are expecting more carbon under biomass crops, but we are expecting this carbon to go deeper down. And we're reasonably convinced that the carbon is going to be more stable because of this whole microbial pump, but we do want to check that and see how that goes. A lot of times it's going to be that it's the root contribution that we're expecting is going to help stabilize that carbon. We've had challenges. Finding a field that has not had a foreign history, especially as one that you're trying to AB it with. One of the ways we've been getting around that is, at least at the research farms, they've got sod on the roadways. So we'll just sort of take it from the side of the road or from the street next to like one of the creeks. That seems typical. We'll see how it goes. These deep cores are actually destroying our toast pounders. So we're trying to figure out maybe a better way to do that. But it's what did the guy say? He says it's a post pounder, not a rock pounder. So all right, well, whatever, that's fine. And then the other challenge has just been finding graduate students. We've had one person in, and they decided to try something different. One of my summer students that was in the previous picture, he will be starting this summer. So that's really great now that he's finished his undergraduate program. So that's the project. And I wanted to maybe turn this into a bit of a discussion. Clearly, I am interested in visiting fields, in particular ones with different cultivars. We don't have to have it replicated. We can find a way around that. But that is something that is interesting to us. I also would like to know a little bit more about anything else about the carbon story in biomass crops at Memphis. So this is me opening the floor to you. What do you think? And questions, of course. We love those questions.